Jmath.
In grade 11, you learned about theory of A and B and A or B. Then we did Venn diagrams. Then we did tree diagrams. And lastly, we did a little bit of contingency tables in some schools. But now grade 12 is a lot different. So grade 12 probability is all about the counting principle. Now, what on earth does that mean? So that is a concept that you use if you need to make a certain amount of choices and you have limited amount of options for each choice. Then you use the counting principles. So let's look at this example first, and then I'll come back to the steps. So how many different party packs can you make if you need to make three choices? Choice 1, Smarties, Astros, or M&Ms. Choice 2, cookies, so Oreos, chocolates, Zoo cookies, and Jolly Jammers. Or choice 3, Coke, Fanta, Sprite, Pepsi, or 7-Up. Okay, so the only thing that you need to do to answer this question is just to say, for choice 1, I have 3 options, then 4 options, then 5 options. And the amount of different party packs that I can make will then be 60 different party packs. So, guys, that's what I mean with these steps. You check how many options are there for each choice, and then you just multiply them. But if they make a certain choice for you, like the second question, what is the probability of a party pack including Oreos and a Coke? Then we're taking away options there. So then it's not 60 possibilities anymore. Okay, so they're saying Oreo, so choice 2, I have chosen, so it's only 1. And choice 3, I've chosen Coke, so it's only 1 there. But they can still choose between Smarties, Astros, and M&Ms, and therefore there will be 3 different party packs that fit those requirements. So the moment they tell you what something is or should be, then you replace it with a times 1. Now, in certain questions, they can ask you for what is the probability of something. Now, remember, probability from primary school is whatever they're asking you divided by all the possible options. So in this case, we saw there were 60 different party packs, and question 2 asked me what is the probability of something, including Oreos and a Coke. So the answer for question 2 would then be 3 divided by 60, which would then just be 1 over 20 or 5%. You can choose if you want to leave it as a fraction or a decimal or whatever. Okay, guys, so that is counting principles. Now you're in grade 12, and there's a reason why this is in grade 12. So it's not going to stay this easy, but that's the foundation of this entire chapter. Question 2, Bafana Bafana has 10 games this season, which they can win, lose, or draw. So I have 3 options for each match. Question 1, how many possible outcomes are there? Okay, so I made 10 spaces. Each of these spaces could be win, lose, or draw. Okay, so I'm just going to 3 times 3 times 3 times 3 times 3, and I can rewrite that as 3 to the power 10. I'm definitely not going to write it out so many times every time. So because it's all the same amount of options, that's why I can rewrite it as an exponent. The previous question was 3 times 4 times 5, so I can't do an exponent there because there isn't something that repeats. But in this case, 3 to the power 10 would be the amount of possible outcomes. And according to my calculator, 3 to the power 10 is actually 59,049. So question 2, if they draw the first 3, how many possible outcomes will then be now? Okay, so remember, if they tell me what happens, I replace it with a 1. And the rest will still be 3s, but there will be less than 10 now. So this answer would then just be 3 to the power 7, and not 3 to the power 10 as the previous one. And 3 to the power 7 would just equal 2187. Okay, guys, so I hope it's making sense. I'm just multiplying how many things can happen. But if they tell me something is certain, then, because remember, probability is what might happen. But if I know for sure they drew the first 3, I'm not going to multiply with what could happen. I know there was just one outcome there. Question 3, what is the probability of the team winning half of their games? Now, it doesn't matter if it must be the first ones or the last ones or alternating or whatever, but half of these I'm going to put as a win. So I'm taking away the options and I'm just rewriting it as ones. But the others could be won or drawn or lost. So I have to replace them all with a 3, and therefore the answer is 3 to the power 5, which is equal to 243. But now, very important, the question was what is the probability? So therefore I need to divide by 3 to the power 10, and I need to divide by 59049, and then you can just see if that can go any simpler, and I think it definitely can. So there we go. There were 2 questions about the basics of counting principles. Let's make it a bit more tricky so you can see what else to expect. So questions that come up very often is where they give you different words or letter arrangements and they ask you a bunch of questions for them. Okay, so just again with the counting principles we just did, if you get a question like this and they say something can be repeated, you will have an exponent setup where the bottom number, the base, is the amount of options I have, but the exponent is the amount of spaces that I have available. Okay, so let's look at a question. Question 1. How many different arrangements can be made if the letters may repeat? And I'm looking at the word lemons. Okay, so there's 6 letters, there's no duplicates, and they are not limiting me to a certain amount of spaces. So for question 1, the answer would then just be 6 options and 6 spaces. My calculator tells me that's 46656. Okay, guys, so you can just write the exponent, but please also type it on your calculator. You're always going to write exam with a calculator in grade 12. I just checked this morning, and all the memos for your November exams want you to have the number and the working out. So please don't forget to write out the number as well. Question 2. How many 4-letter arrangements are possible if the letters may be repeated? Okay, so now I don't have 6 anymore. I now just have 4 spaces. So I'm just drawing the 4 spaces, but it may be repeated. So it can be 4 L's or 4 E's, or I don't know what it's going to be, but there's 6 options in each of the spaces which I am multiplying for that counting principle. So therefore the answer is 6 to the power 4, which would then just be 1296. Question 3, how many arrangements are possible if the letters may not repeat? Okay, so if you think of Scrabble and you have the 6 tiles of lemons on your board, and they're asking you how many different combinations can I make with that? So the first space, I have 6 possibilities, but when I used one, I only have 5 left, and then 4, and then 3, and then 2, and then 1 left for the last space. Okay, so if something may not be repeated, it's going down by 1 each time, and this number would then be 720 if I multiply that. But remember, as I always say, mathematicians will always look for a shortcut, and if they can find a shortcut, then they're going to use it. And if there isn't one, they're probably going to make a shortcut to do this easier. So please look on your calculator in the top right corner. There is an exclamation mark there, and that is called factorial. So in this block to the left, I'm showing you what factorials are. So whenever I have something just like that's on screen now, I have 6 spaces and I'm using it up till I get to 1. I can rewrite that whole thing as 6 factorial, and that would also give me 720. So for any sum where they say something may not be repeated, you can really use the factorial button. Then you don't need to write it out or multiply these things so many times. Now, question 4. How many 4-letter arrangements are possible if the letters may not repeat? Okay, so it's not 6 anymore, so I know it's definitely not 720, but I can just delete the last 2. And then that would be my answer, actually. So for the first space, I still have 6 options, then 5, then 4, then 3. So I can just erase the times 2 times 1, and then I can just get the answer for this. And that would equal 360. Let's look at another question of this type. Consider the word springbok. Okay, not springboks, without the S at the end. How many different arrangements are possible if the letters may repeat? So first count the number of letters in springbok, and it is 9 letters. So it can be repeated, 9 letters, 9 spaces. The answer is just 9 to the power 9. Now, if you type that in your calculator, you are going to get into the millions. If the answers are that high, then sometimes you do not need to write it. If it is my November exam, I'm not going to take any chances. So please write the number out, unless it's something ridiculous with like 15 or 20 digits. Question 2, how many 5-letter arrangements are possible if the letters may repeat? Okay, so I have 5 spaces. I have 9 options for each space. So the answer is just 9 to the power 5. And the answer for that is going to be 59,049. Question 3, how many arrangements are possible if the letters may not repeat? Okay, so remember 9 times 8 times 7 times 6, all the way till I get to 1. And I can write that as 9 factorial. The answer to that would then be 362880. Question 4, how many 5-letter arrangements are possible if the letters may not repeat? And in this case, I am just going to make 5 spaces, and I'm just going to do 9 times 8 times 7 times 6 times 5. And the answer to that would then just be 15120. Question 5, how many arrangements are possible if the first and the last letter must be a vowel and the letters may not repeat? Now, something very awkward, guys, is that so many matrics get these questions wrong because of grade 1 Afrikaans and English. Okay, so please remember, don't tell anyone if you don't know, but now you will know. There's 26 letters in the alphabet. 5 of them are vowels, the other 21 are consonants. Okay, these are the vowels. Okay, so if you didn't know that, now you know that. You should keep that secret till the end. But yeah, I've seen too many people losing marks because they don't know how many letters are there in the alphabet. Okay, so for question 5, it must start and end with one of these 5 letters. Now, if I look at the word springbok, it can only be an I or an O, and an I or an O. But now they're telling me it may not repeat. So for the first space, I have 2 options. But then I've chosen one of them. So for the last space, that one is not repeatable. So therefore, it's a 2 and a 1. Okay, so now for the others, I can now use everything else in the word springbok that wasn't a vowel for the middle spaces. So therefore, this is still 7, 6, 5, 4, 3, 2, and 1. Now, if I look at that closely, the blue numbers will form 7 factorial, and the orange numbers would form 2 factorial, and that would then be my answer. So 10,080 possible combinations if that is the requirement. So now we're going to look at what happens if you have more options than you have spaces. There must be a way to write it as a factorial instead of just writing so many things times each other. So when this happens, you're going to make a fraction and you're going to put all the options on top, factorial, and then divide it by all the ones that you did not use. Okay, so let's look at the first question. 10 contestants line up for the 100-meter final. In how many different ways can the medals be awarded? So remember, a race, if you think of the Olympics, will only have a gold, a silver, and a bronze. So for gold, there's 10 people that want a gold. Now for silver, everybody wants a silver except the person that already has a gold. So that's 9. And then for bronze, those 2 will definitely not want a bronze medal if they can have something better. But the 8 that remain will do anything just to get a medal. So therefore, this would be 8. Okay. So I can just write it like that, and that answer is 720. But the way to write it as a factorial would be all of the people that started the race divided by the ones that won nothing. Okay, and if I type that in a calculator, it would still give me 720. The next question. A company has 9 vacant positions, but 20 people apply for a job. In how many different ways can the positions be filled? Okay, guys, now I definitely don't want to write 9 spaces and multiply the numbers 20 times 19 times 18. I can do that if I forget everything in an exam. Please do that to get your marks. You will get full marks if you do that. But the right way to do it would be everybody that applied for a job divided by everyone who did not get a job. Okay, so when I type this in, I got a scientific notation answer, but don't take chances. Please just write it down. It's starting to get a bit ridiculous with how big it is, but you never know when they will take away a mark if you don't write this number. So that's how many different ways those positions can be filled. There we go. That was the basics of the fundamental counting principle that you're learning in grade 12. We will do a few more videos and practice videos with other variations that you can expect in an exam. So please go through them. Make sure you know this. It really doesn't count a lot in your paper, but you don't want to leave blank spaces because you didn't study this.
If this video helped you, please like and subscribe.
Jmath.